Good morning. Today's class is regarding the named reaction, that is Reimer Tiemann reaction. Reimer Tiemann reaction, and it is one of the popular named reactions in organic chemistry. This can be simply statemented as formylation of phenol with chloroform in alkaline medium. Okay. So formylation, coming to the term formyl, what does it mean by formyl? It is a simple aldehyde group. So let me develop the reaction for this statement. Take the phenol molecule, and to the phenol molecule you simply add some chloroform, trichloromethane, and the alkaline medium is provided with the help of potassium hydroxide, and you will get two different products, that is the addition of aldehyde group at ortho position with respect to phenol moiety, or that is the other product at the same addition of aldehyde group at para position with respect to phenol moiety. Okay, these two are known as regioisomers. So because the chemical group, the same molecular formula, the chemical group differs in the location or position or the region within the molecule, therefore they are regioisomers. And coming to their names as well, their names are ortho hydroxybenzaldehyde, because of the two chemical groups, this is aldehyde and alcohol groups. Aldehyde is more prioritized than alcohol, therefore numbering starts from aldehyde attached carbon. Okay, so 1, 2, 3, 4, 5 and 6. The same thing here also. This is starts with aldehyde center, and you can go with the clockwise direction or anti-clockwise direction, because in both the cases you will get a fourth position to alcohol function. Okay, therefore it is ortho-hydroxybenzaldehyde or 2-hydroxybenzaldehyde, and in the same way it is para-hydroxybenzaldehyde or 4-hydroxybenzaldehyde. Okay, so now coming to the mechanism of this reaction, the generation of step involves generation of dichlorocarbene. So see, it is consider this as chloroform molecule, and when this chloroform molecule is initially attacked by hydroxy moiety, and it abstracts the proton from trichloromethane and it eliminated as water molecule, and you are left with CCl3 minus, and the CCl3 minus, and further continuation of the reaction, see this chlorine, one of the three chlorines on the molecule, will be eliminated as chloride ion with the electron from carbon as well. So now see, in the initial step the carbon abstracted electron from hydrogen, and in the next step the chlorine eliminated chlorine is moving away from the electron from carbon. So carbon gained one from hydrogen, carbon is losing one to chlorine, therefore it stays as neutral. The carbon molecule, carbon center stays as neutral, and this neutral 2 electron containing species is known as carbene, and as it has got two chlorine centers, this is dichlorocarbene. Now this dichlorocarbene, in the further steps, see this is phenol, and this phenol again in the presence of basic moiety, this phenol acts as an acid now, and this is base, so you will get an ion now. So this hydroxide center takes away the proton and leaving behind the electron of hydrogen to the oxygen, and you will get a phenoxide ion. This phenoxide ion, see, it participates in resonance, and you will get a negative center at ortho position. Okay, so this is phenoxide ion resonance, one of the resonating structures here, and this resonating structure now Let me go with the other side as well. This is second resonating structure, negative charge over para position, and this is double bonded O, and again it again participates in resonance, and you will get the negative charge at other ortho position with the double bonded O. This is first resonance, this is second resonance, this is third resonating structure. And now you can go with any of the resonating structures. So let me take for our simplicity, the negative charge is considered it is localized on right side. Okay, so this phenoxide ion now attacks this dichlorocarbene, okay, with its excess electron, and you will see here there is a bond formed between these two. And now see, previously this carbon is neutral and it is accepting one excess electron from phenol moiety, therefore it becomes a negative charged, and there is one more hydrogen. Okay, you don't leave that behind. Okay, now this hydrogen center, keep it as it is, and this is double bonded O. Okay, now this bond is now in the further reaction, this bond, this carbon hydrogen bond shifts to this benzene, generating oxide ion again, and this outgoing proton is abstracted by carbon ion center, and you will get a double bond, double bond, double bond, and this is oxide ion, and this is CHCl2 center. Okay, this negative charge again moves into the ring, and this bond shifts over here, and one of the chlorine center eliminated as a chloride ion again, and you will get a double bond over here, and this is CHCl. This molecule now again attacked by a hydroxide ion, and this bond shifts back again. You will get a double bond. Sorry, let me paste the bonds as it is. This is hydrogen, hydroxyl ion, and one more chlorine as it is, and this effect again you will see here, double bond, and here it is double bonded O, and this is H and OH. Again it is attacked by hydroxyl center, and you will see here its movement. So overall this is phenoxide again generated, hydrogen, and now you can see now in the center I have got a carbon with the two hydroxyl centers. This is a geminal diol center. Okay, these geminal diol centers are usually unstable, and they simply eliminate water molecule, and you will see a simple hydroxyl group over here, and this is C double bond OH. The same reaction can be expected for a para hydroxybenzaldehyde as well. Okay, so we can get over here phenoxide ion generated, and this is CCl2 dichlorocarbene. Okay, this bond moves over here. Okay, and this bond shifts here, and this bond from the center attacks this dichlorocarbene, and you will get C, Cl, and Cl with a negative charge over here, and one more hydrogen. Okay, this is double bonded one, and this bond shifts back. Okay, and this proton is abstracted, and you will see CHCl2, and it's simple phenoxide center. Okay, and this molecule again with the two hydroxyl centers eliminates two chloride centers, and you will get a para hydroxybenzaldehyde center. Like after all these, for these two, or you can also go with the ortho moiety as well, O minus C double bond OH, and these two forms, and after this you will do bunching of the reaction, where you will get a OH and C double bond OH. This is ortho hydroxybenzaldehyde and para hydroxybenzaldehyde. Okay, and once again I am repeating, these two are regioisomers, or you can also spell it as positional isomers. because the position of one of the moiety or an atom or a group is changed or differs between these two. Okay, and one more point I want to stress over here is these two differs in boiling point. I'm stressing this point. These two differs in boiling point, because in orthohydroxybenzaldehyde you will see intramolecular hydrogen bonding, intramolecular hydrogen bonding, whereas in para-hydroxybenzaldehyde there is no possibility for intramolecular hydrogen bonding, but there is possibility for intermolecular hydrogen bonding. Because of this nature, see, whenever you go with a para-hydroxybenzaldehyde, there is a possibility of two molecules binding to each other due to intermolecular hydrogen bonding. And you will take these two different solutions and simply heat them. Due to this intermolecular hydrogen bonding, para-hydroxybenzaldehyde don't get boiled out or don't get evaporated easily. Okay, whereas in the other case, in orthohydroxybenzaldehyde, there is no such situation. Therefore, these orthohydroxybenzaldehyde molecules easily take up the temperature and they'll get heated up and they'll be converted into vapor states. Okay, therefore these two compounds, like after completion of this reaction, after completion of Reimer Tiemann reaction, if there is a situation to separate these two compounds, orthohydroxybenzaldehyde and para-hydroxybenzaldehyde, you can simply make use of distillation or boiling point difference. Okay, thank you.